Welcome back. Next up, we have Alessya Visnjic, the CEO of WhyLabs. Please join me in welcoming Alessya to the stage.
Thank you, Rachel. Really excited to be here and excited to talk about machine learning governance. Hello, everyone. Thank you for joining AI for 2021. My name is Alessya Visnjic. I am the CEO at WhyLabs, the AI observability company. And today I would like to present a few best practices for implementing machine learning governance, focusing on practical things a team can do today to get closer to establishing a responsible AI practice. So why is machine learning governance on our minds? Well, while organizations today are getting more adept at successfully deploying AI to production environments, once in production, AI applications fail in unanticipated ways and prove difficult to operate. As of today, over 1,000 AI failures have been recorded by the Partnership on AI and an AI incident database. This indicates how frequently AI failures make the news and end up in the AI incident database. If your team runs AI in production, you probably have a story yourself of how it failed and upset your customers, just like Andreas here, who got recommended a pepper as a substitute for roses by the Whole Foods algorithm. It's a very harmless failure, but a frustrating customer experience. Therefore, machine learning governance is the practice that focuses on helping teams manage the risks associated with running machine learning for customer impacting and business impacting decisions, in case these decisions fail in unanticipated ways. Assessing these risks requires a combination of executive, operational, legal, ethical, regulatory, and technical perspectives, a lot of things. Well, to help this, there is an array of regulations, checklists, platforms, and best practices that guide any organization towards implementing machine learning governance. Specific implementation of machine learning governance depends on the industry vertical, on the class of models that are used, and on the importance of decisions that are made by a given model. However, no matter what industry vertical you're in or what type of model you're running or developing, there are two guiding principles you can focus on first. One is the human-centric principle, and the other one is the transparency principle. Now that we have simplified things significantly, let's dive deep into each one of these principles. The human-centric AI principle focuses on the fact that machine learning systems are built by humans and around humans. Machine learning systems ultimately augment human decision-making using historical data generated by human decision-making to inform machine learning decisions. Therefore, it's absolutely key to begin any machine learning project with a clear outline of roles and responsibilities of who will be building and operating these systems. Including domain experts and end users in designing, testing, and evaluating AI and ML systems is an absolutely critical starting point. Next, every machine learning project must have mechanisms for human control, both at the design phase and in the operation phase. And finally, there must be mechanisms for end user feedback. In many AI systems, such mechanisms are the only way to indicate if an AI system is not working as desired. For example, in the recommender system, if you're browsing Netflix and you're getting recommendations, if you're not clicking on them, that is a minor indicator that the recommendations are not working. However, if you're able to provide feedback, let's say a thumbs up or thumbs down or thumbs up, you can explicitly indicate that the recommendation does not resonate with you. Now, for the transparency principle, we'd like to highlight the tools that should be available to the team to ensure that machine learning is developing the impact that it was designed to deliver. There are three categories of tools that are critical for a successful machine learning deployment and development. And these tools should be established at the very beginning of the machine learning development process, at the very beginning of the project. So let's talk about these tools. First, a team must have the tools for interpreting and explaining AI decisions. This is table stakes. These tools help with operating the system and help end users understand the reasoning behind machine learning or AI decision. Second, a team must have the tools to keep track of the system status, the tools that help maintain rich data about the composition of the machine learning system and help understand how it changes over time. And finally, a team must have the tools for measuring the quality of AI decisions over time. Since model performance naturally degrades over time due to data and concept drifts, it's critical to continuously monitor machine learning performance as well as the data that flows into the machine learning system. Like I said, these three things are basically table stakes for implementing transparency in a machine learning system. So in the next few slides, I would like to share open source tools that have been successfully used in organizations to reach AI transparency. First category of tools are the tools for interpretability and explainability. These tools help teams in two key ways. First, they help an operator explain the behavior of the system. This is done for the purpose of debugging, auditing, and documenting. Second, these tools help an operator extract an explanation for a customer who would like to get an explanation of the automated decision. For example, if a customer is given a decision of whether they're getting a credit card or not, a human operator should be able to extract an explanation with attributes that influenced that decision. Now, there are dozens of open source tools out there, but these two have been widely adopted in organizations and can be picked up by your team today. One of them is SHAP and another one is interpretability. Check them out. Now, appropriate tools for documenting the system status must start with proper version control. In machine learning systems, version control is not only about capturing the code, it's also about keeping track of the model design and evaluation assumptions, keeping track about the training and evaluation data, and keeping track about the rich model metadata. To do that, there are a handful of tools that are available, but there are two that specifically stand out. One is MLflow and the other one is DVC. These are the two popular libraries that help with establishing what's called version control in the machine learning system. MLflow keeps track of machine learning system artifacts, and DVC keeps track of data artifacts. Check them out for your machine learning system. Now, the last step in establishing transparency is measuring the quality of decisions that the AI system makes and measuring them continuously. That's key. This is tricky because machine learning systems are constantly flowing and crunching data. In some cases, the teams don't even keep a record of what data was processed because of the huge volume of data. So the data is ephemeral, but the data also powers the decisions that the machine learning system makes. So when you're tasked with answering a question about the quality of model decisions or about model behavior, you have to reproduce an entire data flow in order to arrive at the answer for that question. And this property of the system makes it especially hard to continuously evaluate the decisions that the system is making, to continuously measure the quality and to root cause issues that arise, which is why there has been a tooling gap to address this. So after many years of supporting production machine learning systems, my team and I at WhyLabs set out to build a solution for continuously tracking data and models to help teams measure what matters in their machine learning systems. We made YLogs available as an open source library under Apache 2.0 license because we believe that every team must have access to continuous machine learning system monitoring. YLogs acts as a logger, capturing key information about the model and the data that enters and exits the model at any point in time. With YLogs, teams can measure data quality, model output quality, and model performance continuously over time or investigate it at any given point in time in the past. And finally, with YLogs, teams can slice the model performance data into meaningful segments to evaluate for fairness and bias. So to recap, we discussed two key aspects of machine learning governance: the human centricity and the transparency aspect. No matter what stage of AI adoption your team is in today, you can start implementing these principles right now. Specifically for transparency, these open source tools will help you jumpstart your AI team's governance journey. So to conclude, I would love to invite anybody who is thinking about machine learning governance and transparency to join the effort of developing open standards and tooling for AI transparency with YLogs. You can join our Slack community to discuss these tools, or you can contribute to the open source library and join the effort of developing the open standard for AI transparency. Thank you.
Thanks, Alessya. Audience, it's time to make your way to our next session. On your way, don't forget to stop and check out our amazing exhibitors.